Yeah, so we carry on with common base analysis. We're busy with the DC part, and we are through with that. So as we look into the AC part, analysis part, AC analysis, of course, capacitors behave now like short circuits. What is the impact of that on our circuit is that CB will short the base, and since RB1 as well as RB2, because voltage sources become equal to ground, so RB1 and RB2 are in parallel and they will all be in parallel of 0 ohms, so that will result basically in just having ground on the base. Very important to notice that. And then we go to the base, and as we go to the base we will have we go from the base to the emitter, and on the emitter side we're gonna have RS, of course, and from RS we will go to our VS. We're gonna have VS, sorry, the source voltage, in such a way that VI is appearing there, of course, after RS, because part of VS get consumed by RS and only VI gets to the input, which is the emitter pin in this case. On the collector side, we will have RC going to ground because, well, VCC, which was a DC voltage source, has become ground. And we will also have, since the capacitor going to output C out is now short circuited, we're gonna go through RL also to ground. So that's the emitter where the input is, that the collector where the output is, and the base from which we observe. So in terms of the output, we observe Z out, which is the same as R out, output impedance or output resistance from there. And we're gonna observe, of course we still have to replace the transistor by its AC equivalent circuit just now, and but we know for sure that we're gonna observe R in from that point inward as well, R in Z in. So that's not a complete small signal AC equivalent circuit. To have it complete, we have to put the transistors equivalent circuit, and for common base it's preferable to use the T model. And if we use the T model, as we come in through the base, we reach that point, which is still the base point. We've got on the collector side, we have on the collector side, sorry, as we come into the base, on the collector side we've got IB flowing into there, with IC, which is beta IB, which is the same as GMV pi, going that way. We go to the collector, and on the collector side we've got RC connected there, as well as RL, as we picked up. Then on the we go to the emitter through RE, all the way to the emitter, and on the emitter we reach, basically when we reach the emitter, that's our input line, our VI line, and then we go through RS to reach VS all the way to ground on this side. That will be the full small signal analysis equivalent circuit of the amplifier design, but we're using the T model in here.